Welcome to Future Talk. On today's program, we're going to talk about some of the latest developments in how human beings interact with computers. Andy Hertzfeld was one of the key designers of the original Macintosh computer and played a major role in developing its graphical user interface. Since leaving Apple, he co-founded several other companies, including General Magic, and he currently works for Google, and is the author of Revolution in the Valley, a book about the early days of the Macintosh, and he's also the creator of folklore.org, a website devoted to collective historical storytelling. Isaac Majerowicz is originally from Colombia, South America, and has electrical engineering degrees from both Caltech and the University of the Andes in Bogota, where he also served as Dean of the Electrical Engineering Department. He's been at Cisco Systems since 1995 and is currently a product manager at the Cisco Networking Academy. He's going to talk about the fast-growing field of telepresencing. Also with us is visual journalist Eileen Clegg. Eileen is the founder of a company called Visual Insight, and she works for companies large and small, drawing murals in real time that capture the essence of innovative ideas. She'll be drawing her interpretation of our conversation today, and at the end of the show, we'll look at it and see what it can tell us. And you were involved in the very earliest stages of the Macintosh. You were one of the key designers of it. What can you tell us about the culture at Apple or the vision of Apple that made it possible to produce something that was so far outside the box at that time?
Well, I think it started with the values and personalities of the founders, especially Steve Wozniak, but also Steve Jobs. The Apple II was not, which was really the first big product for Apple, was not thought of or conceived of as a product. It was a labor of love. It was Woz's lifetime dream, and he approached it more like an artist, really, than an engineer. And so Apple was gifted with this work of genius. Woz is an amazing genius, using original techniques that no one had ever thought of before to deliver an incredible experience for the time at a price affordable to individuals. So the Apple II and other computers at the time were the first computers, were so exciting because they were the first computers that an ordinary person could have. But they were still a little too hard to use. They weren't powerful enough to create a great user experience. So the Macintosh was sort of the reincarnation of the Apple II for the 80s, where we were able to use the advances in the underlying technology for the very first time to make a computer that's both affordable and enjoyable to use.
Now, is this a culture that was consciously created, or did it take just several extraordinary individuals to do it? What I'm asking is it possible to intentionally create this kind of culture, or does it just have to happen kind of accidentally?
Well, I would say extraordinary individuals, again, starting with Steve Wozniak and Steve Jobs, two of the most extraordinary individuals I've ever met, working mainly out of their passion. I would say the single secret to doing what Apple did is the people working on the products were working on something they wanted for themselves more than anything else in the world. So they filled it with love and passion, and you don't have to do market research when what you're creating is the thing you want the most.
Now, we have some slides of some of the early days at Apple, so let's go ahead and show the first one of those slides.
That's a photo taken by...
That's your book.
Yeah, that's the cover of my book, actually, based on a photo taken by a fellow named Norman Seeff around the time of the Macintosh introduction. That was taken in December 1983, and those are some of the key designers of the Macintosh.
That's you in the middle, standing up.
Me in the middle, Burl Smith and Bill Atkinson on both sides of me, Burl holding the keyboard, Bill holding the Mac. Joanna Hoffman, another amazing person who was the first marketing person for the Mac. At the very left is George Crow, who designed the analog electronics. On the far right is Jerry Manick, who designed the case for the Apple II and led the team that did the industrial design for the Macintosh.
Okay, let's take a look at the next slide now.
That's the Mac software team.
So you guys had some fun, too. You weren't just programming all the time.
Demonstrating teamwork and how we built on top of each other's work. That pyramid, though, only lasted for a few seconds.
Building on each other, that's sort of a good way of looking. There's you in the red shirt.
Yes.
Okay, let's look at the next slide.
That's a collage, actually, that was done for the 10th anniversary of the Macintosh, with pictures of some of the key creators. Myself, Bill Atkinson, Burl Smith, Susan Kerr, who was the artist who designed the icons and fonts for the Macintosh. At the lower left there is Steve Jobs, a man who needs no introduction.
And the person on the television screen was?
That was Jeff Raskin, the brilliant man who conceived of the original Macintosh.
Okay, and here it looks like a coming out party.
And that was on the doorstep of the building we all worked in right before the Macintosh came out. This was the team of 100 people who built the original Macintosh.
And we have one more slide.
Finally, yeah, that one was taken at my 40th birthday party in 1993. I'm at the very left, Bill Atkinson in the blue shirt, Bud Tribble, who was really the very first Macintosh programmer, and Steve Jobs on the right.
You still keep in touch with those guys?
Yeah, I'm still really close to all the core key creators of the Macintosh are like my extended family.
Now, after you left Apple, you worked at a number of other companies. In fact, you co-founded several companies. Did you do any work in those companies that contributed to the overall theme of human-computer interaction?
You bet. At General Magic, we pioneered a product category called Personal Intelligent Communicators. That was probably a good 10 to 15 years ahead of its time. You could consider what we built, these Magic App devices, as the iPhone of the mid-90s. Very similar type of aspiration because they were fundamentally communicators. You use them to, they were highly graphical, and you'd send little electronic postcards back and forth with them. This is in an era before email was widely used.
So the idea is that people prefer pictures to text. It's easier to relate to a picture than to read a bunch of text.
Sure, depending on what it's for. Text certainly has its place, but graphics can be much more intuitive.
Now, I understand you're working at Google now. What can you tell us about your work without giving away too many company secrets?
Well, I can talk about a product I developed for them last year called Google News Timeline, which I tried to create something that was sort of like Google Maps is for the dimension of space. I tried to create something similar for the dimension of time, where you can explore time in a Zoom-based user interface. And
you mean like history
aggregate
going
information.
Back?
Yeah, back to I have the most important events in the history of mankind going back to the 11th century in there, but you can go to any particular period of time and see periodicals like Time Magazine or Popular Science, as well as all kinds of other information.
So it sounds like you can take events that are far apart in time and space and bring them together, connect them in a way that you could not do easily otherwise. And I think one of the most important things about computers is the ability for pattern recognition.
Sure.
Which enables you to see connections you couldn't see otherwise.
Yeah, well, I was trying to put things in perspective and really create a map of the culture, the zeitgeist. And it's amazing how the magazine covers, like the Time magazine covers, when lined up in a temporal sequence, can really show how the zeitgeist evolves.
Well, what do you think are some of the most interesting things going on right now, the most interesting developments in terms of the interface between people and computers?
Well, I think we're in a period of really a revolutionary change in user interfaces, where we're transitioning to what I would call natural user interfaces. Instead of having to manipulate the computer itself like you do with the mouse or the keyboard, the computer does the work to watch you. Like the iPhone, there's no mouse, it's just you, your fingers. The new generation of video games, including Microsoft's very interesting Kinect product, the Sony Move, and Nintendo, who pioneered it in the video game industry with the Wii, featured natural interfaces where you interact with the computer with just gestures of your body. In a way, the computer disappears and watches you. But you can also fit into that category voice user interfaces. Again, where I don't have to use any device, I just say something, and the computer listens, comprehends, and takes action.
Well, I've seen some stories where you can actually control things with your mind as easily as you move the muscles of your body. You just think about moving your arm, and it moves. And I've seen stories where they basically capture that impulse and make it move an external object.
Sure, and the best way to really read your mind, you can't do that. You can sense your brain waves, but to do that at high resolution, you probably have to wear a funny hat or something that you don't want to. But so the way it can read your mind is just by watching your eyes move. And that's a very good proxy for what you're thinking.
So do you think we're getting to the point that we won't be able to do anything without a computer of some kind?
No, no, I don't think so. There's some activities really you don't need a computer for. You know, I'm not going to depend on my computer to sleep or to exercise, but I think computers are enhancing the life of the mind, really, not so much your physical life.
Now, when we talk about computers, computers are not just machines that sit on your desk and you type with a typewriter or a keyboard. Computers are in all kinds of devices, for example, cars. And I understand that Google is working on a project to drive cars automatically, cars that drive in traffic under all traffic conditions without a human behind the wheel.
Yeah, that's one of the really far out things Google was working on. That was they've been working on it for 4 or 5 years, but it was a big secret that I wouldn't be allowed to talk about, except that about a month and a half ago, Google announced the project. This is something with a pretty far, I wouldn't expect to be able to buy one next year. I think when we announced it, we said it's probably got about an 8 to 10 year time frame to be commercialized. But these are cars that have been driving right around here, Palo Alto, Mountain View, and Highway 101 that completely drive themselves.
I assume there's a human being in a manual override just in case.
Yeah, just to meet legal requirements, there actually have to be 2 people in the car, including a guy in the driver's seat that can override it at any thing. But the only accidents, they've never had to override it. They were in one accident where someone rear-ended the car.
But I would think you would have to solve a huge number of problems. The car would have to have probably a camera mounted on the roof with 360-degree vision. It would have to be able to differentiate between moving objects such as cars and stationary objects such as trees.
Yes.
It has to calculate the speed and distance of all cars.
It has to read the text on the street signs to know a one-way street, the stop signs, the traffic signals, and of course pedestrians.
Right. It has to be able to see the lane dividers, and sometimes those are not that visible.
Yes. Yet, you know, you might have thought it was science fiction a few years ago, but it's actually quite a feasible, practical thing that ultimately will save tens of thousands of lives per year in the next decade or two.
Yeah. Do you think it's possible that people might be becoming overly dependent on computers and losing skills where they had to do things by themselves before? Now I can rely on a computer to do everything for me. When pocket calculators first came out, people said, well, kids aren't going to learn multiplication tables anymore.
Well, that's a pretty good analogy. We've lived with the calculators now for a couple decades, and kids still do learn to multiply. Although now they can multiply with the aid of the calculator, you know, 10-digit numbers. So really the computers are augmenting our intellect. You know, computers are technology, and of course they can be used in ways that diminish human potential. But what I'm excited about is they can maximize human potential. And I think there are so many endeavors now and related fields where breakthroughs are made possible by computers. Like you wouldn't have biotech if you didn't have more and more powerful computers.
You just couldn't analyze the data at all.
Yeah,
Yeah.
It's almost any you know, sort of worthwhile endeavor is going to leverage the fantastic capabilities that the computers bring to us.
Well, one of the things that people use most often in computers is search, and Google is, of course, at the top of the heap with this. So right now you type in a search term and it goes and looks for it. Can we expect any major changes in the way search is done to get, you know, more intuitive results?
Well, Google just launched 2 major changes in search in the last month and a half, including one just this week. I don't know if you know about it, which they call instant previews, where now you can mouse over a little magnifying glass included in the search results and see the web page right on the search result page without going to it. So you can quickly preview the page to see if it's one that's worth clicking on.
Now, there's also something being developed called the Semantic Web, in which apparently it understands the language. The way I understand it, Google right now doesn't really know what the words mean, but it checks for the frequency and so on, whereas in the Semantic Web, it has a better understanding of the context of the search.
Actually, Google does a lot of work to understand what the words mean, and there's lots of ways you can demonstrate that. But what the Semantic Web does is allow the web page designers to express the meaning right in the markup of the page itself. So it makes it easier for computers to understand the page. But Google wants to do a great job, so it, even without that markup, can understand the meaning of both your query and the web pages to give you the best results.
Mm-hmm. So do you think that computers are changing the way humans think? By interacting with computers, our thought processes change. We get maybe sharper, maybe less frills, more to the point. Maybe, I mean, do you think, like when you interact with a tool?
Well, you know, computers, I mean, people have always co-evolved with their environments. So with this incredible tool, which can augment us by doing some things like calculations and pattern recognition that we're not so great at, you know, it changes us for the better, I think.
Okay, we're going to move on to our next segment now. I'm going to be speaking to Isaac Majerowicz, but first, let's see how Eileen Clegg is doing. Eileen, how's it going with your mural?
Well, the story's shaping up here visually as well. We've got the genius beginnings of Apple, and then moving into the present, a Mobius strip for the next revolution. And nicely, your Google Maps timeline also provides a path for the car. So we're really actually showing this progress, as you said, started back in the 90s, and with something similar and moving into the future.
Great, we'll be getting back to you near the end of the show and looking at your work in a little more detail.
Good.
Okay, I'm now talking to Isaac Majerowicz, a product manager at Cisco Systems, and you've been involved with something called telepresencing. What exactly is that?
Well, telepresencing is an interesting concept that probably works over the very well known and very little used concept of video conferencing and other tools or applications that people use to communicate remotely. And I would say that telepresence is a great example that evolves on the human-computer interaction to go to more a human-to-human interaction using the technology as the means to facilitate that interaction. So what telepresence does is provides you a more realistic experience when individuals or groups of individuals have to interact remotely for a particular purpose, like a meeting or a training or any other application like that.
Now we have a video that demonstrates one of the uses of telepresence. We're going to show that video and then come back and talk some more. So let's go ahead and roll that tape.
Cisco Telepresence, bringing people and countries a little closer. That's the human network effect. Cisco, welcome to the human network.
Okay, so that video was put together by Cisco, your employer, and they're obviously a leader in telepresencing. Now, one of the obvious uses is business meetings. What are some of the other applications that telepresencing can be used for?
Well, anything that has the capacity to put groups of people together for a particular purpose, being training or just a business conversation or some type of interaction will have, use of telepresence. medicine is a big user of telepresence.
So you could visit your doctor even though you're in different locations?
Right, and it allows you to for example, have very good specialists, doctors that are unique in something, they are specialists in something, have access to people that would not have access to those type of specialists normally. And the interaction is not only the possibility of that doctor to see you, to feel you, probably remotely by using other person that is with that patient remotely, but also eventually to advise or help in a surgery if necessary, because again, the experience that telepresence gives you is a little bit or very similar to that person being there.
And I understand that there's also computerized equipment that can, take your vital signs, and that can be transmitted over the computer. So while the doctor is looking at your rash or whatever it is, he can also be getting an instant real-time readout about, blood pressure and heart rate and things like that.
Exactly, and that's a very true statement. Everything that has to do with exchanging communication, it's in a form of a document or a video or a drawing or something that you want to share with the people that are remotely, could be very well combined with telepresence. So the person that is on the other side has the capacity to look at all these pieces of information.
So what it is, basically you have a large television screen, and there's a television camera mounted on the screen, similar to the way a lot of people have webcams today.
Right.
But so can this be done in any size? I mean, is it portable? Like on that video we saw, this was an enormous screen. But if I'm wandering around in the middle of a forest somewhere, only with what I can carry in my backpack, could I set up an instant telepresencing thing and talk to somebody?
Right. Yeah. Depending on the resources that you have on hand, you can do a little bit of that, because all you need is basically a high definition camera, a high definition TV set or projector. Things that can provide that. You need a microphone. You need a speaker, so that you can communicate voice, video, and whatever other type of information you need. So some type of collaboration tools to share documents or things of that sort. With a PC or with a laptop or with a Macintosh, being anywhere in the world, you could eventually be integrated in a telepresence session.
So everything is going over the standard internet, all of the data is going. And are today's broadband speeds good enough for that, or do you need something a little faster?
Well, one of the premises of telepresence is that if you want to be as realistic as possible, you're talking about things like high definition television, right? Which by definition is very heavy in content. So not only you need the right broadband and the right services for a network or from a network, you also need to be able to compress a signal to be able to send it through a normal network. So when you talk about telepresence, it's not only the video equipment, you have to have all the additional equipment that compresses the video signal to make it possible to be transmitted through a normal internet connection. That's the mystery, that everybody with a normal, broadband typical connection should be able to participate in a telepresence session.
Now, is this usually a one-to-one connection or a many-to-many, where 10 people all sitting in their offices, all next to a screen, can all see the other 9 people?
Yes, you have, the system allows you to connect up to 48 different camera streams or video streams. So you could have, in principle, 48 people, 48 groups participating from 48 cities in 48 countries in one single telepresence session. So one of the great benefits, for example, from a business perspective, is not only that telepresence can replace traveling, it makes traveling to multiple sites at the same time possible. So an executive from a company could be talking to their sales executives, for example, in 10 different branches at the same time, giving that realistic impression that they were talking in person.
Now, what about security? Maybe you're having a meeting where you're discussing things that should not be revealed to outsiders. Can you make sure that people can't capture the transmissions?
I think one of the great benefits of telepresence is that it runs on a regular network, which means that it uses all the services of a network. So in the same way that you can secure a remote connection using things like technologies like VPN, virtual private networks, You can do that for telepresence. So you can keep a very, very private conversation using the highest levels of security that you can attain in the internet, which can be very, very high.
Now, is this going to be affordable to ordinary people, or is this still mostly for corporations?
Well, that's a great question, because Cisco realizes that the consumer, the end consumer, people like ourselves eventually could benefit from telepresence. And there is a great element that a lot of people already have in their houses. You already have probably a large television set, high definition television set. So if you add a camera and you add a little bit of equipment to that, you could have a telepresence session. The only thing that Cisco will do, and it just released a version of telepresence for end consumers called Yumi, that's the name that it's giving to the system, is that you have to subscribe to a service, and that service provides all the infrastructure, back-end infrastructure that you need to communicate with other people.
Okay, I've just gotten the signal that we just have a couple of minutes left, so let's now turn to our artist, Eileen Clegg. Eileen, what have you got?
Well, I told you how the story began here, which was with the Apple II and that group, which we have the pyramid here. So you have the story, the human story there. It's really important. And what you've come to here later on, talking about all the many innovations, is now we have a global communication capacity where people all over the world in their homes eventually would be able to talk with one another. So what you were saying about technology disappearing, and what we have are all these capabilities now that you don't even have to see the machine anymore. Okay. So that's the story.
And we are going to post this picture on our website. You'll be able to see it. And the benefits of a picture like this is that you can look at it at any time, and it'll refresh your memory if you saw the show, or maybe it'll give you new ideas if you didn't see the show. We've got a wrap. I'd like to thank my guests, Andy Hertzfeld, Isaac Majerowicz, Eileen Clegg. Thanks for coming. I'm Marty Wasserman. See you next time. Okay, so that's it.